What's going on, guys? Welcome back. My name is Brandon. Today we've got a welding and fabrication project. We're going to be building some sort of bracket for a lift. Stick around. This is what we're working with today, guys. This is some 2x2 by 3/16 angle iron. This total project is going to cost the customer $278. I'll show you what we're going to be building. This is an angle iron frame, so it's going to have a piece of angle iron this way, 32 inches long. It's going to have a miter joint, another piece of angle this way that's 23 inches long, another piece of angle iron this way that's 23 inches long, and another piece of angle iron this way that's 50 inches long. On the end of this angle is going to be a piece of 4-inch flat bar, 1/4 inch thick, 8 inches long. So I ended up picking up a drop. We're going to end up plasma cutting this into a piece of 4x8 flat bar. And we're also going to have to bore some 1/2-inch holes along this and along this leg here, because this bracket is getting, I guess, bolted to a block wall as well as this. Then when we're all done, we're going to just spray it with a coat of black paint. Here's the breakdown. Here's the quote of materials. Materials cost me $60. I marked them up 30% because I went and picked them up. So the material total was $78. I've got 2.5 hours of labor at $80 an hour. That's $200 in labor. Total project $278. And I made a note. My customer asked if I have PayPal, which I do, and I will invoice them through PayPal. I love to share the inner working parts of all of the business aspect end of it for you guys, because it gives you guys an idea of maybe what you can charge, because I know that a lot of you guys that are watching this may be considering picking up some side jobs or maybe even starting your own business. Pretty typical MIG welding labor rate for a self-employed person in our area would be about $80 an hour. That's a reasonable charge for the market for the area that I'm in. I charge $80 an hour labor for just general welding and fabrication. Other things cost more. Like if I'm doing something specialty for someone, which is like repairing cast iron or something like that, or TIG welding, stuff like that, that costs more because it's more intricate, it's more involved, it's more tedious work. But for general welding and general fabrication, I charge $80 an hour. I also have a labor rate that I charge by the inch for weld and per cut. That comes into play at different times. Continue to watch this channel and you'll see when I incorporate those strategies in. But this is just some basic fabrication. Pretty simple. We'll be able to bust this out pretty quick and get this customer back in business. So the first thing I'm going to do is start getting my cut list together of the things that I need to cut. You see, I'm also going to have some 1/2-inch holes, 4 of them, in this leg, which is a 32-inch leg. I need to drill my holes. It's going to make things a lot easier if I drill my holes before I start welding this frame up. And to drill these holes, I'm going to be doing this on my mag drill that I built. And if you guys haven't seen this build, it's awesome. I picked this whole base up. So everything you see here in this stand, which is all adjustable through this crank, I paid $35 for this because it actually had a regular drill head on the top of this, but the motor was blown in it and everything was all clapped out and it was super loose. So what I ended up doing is modifying this column and welding this steel plate to it. And now I just take my mag drill, set that on there, and turn on the magnet on the back. It magnetizes itself to this. And now I've got an adjustable drill press stand, and then when I don't want to use it as a drill press, I can just carry it to the job site and use it like a regular mag drill. So get double duty use out of this tool, so it's awesome. I've got a set of annular cutters that I use with this, and it just makes hole drilling so much easier. It goes super fast. So what I'm going to do is I'm going to start cutting some of the pieces up. Now, if you look at these measurements, you can see I got a 50-inch piece. That is from the outside edge of this angle to the face of this plate. So this piece of angle right here really isn't 50 inches long. It's 50 to the plate. So I got to subtract the plate thickness, 1/4 inch there, Then I've got to subtract the 3/16 thickness of the angle on this side. So we're going to be subtracting 3/16 plus 1/4, and that'll be the length of this angle. So this piece right here that's marked as 50 inches long to the face of that, I actually need to make that piece 49.5 inches long so that it finishes out to 50 inches when I'm done. One of the first things I like to do, guys, is check and verify to make sure that the side that I'm going to keep, that the cut from the factory is actually straight, and it is, because there'll be times when it's not, and if this isn't straight, it's going to mess up your overall measurement. So if this is the piece that you're going to keep, you should always get into the habit of checking to make sure that that cut is straight. Just don't take it for granted that it is. So I'll get a nice crisp mark on here, and we can get this cut at 49.5. This saw is going to be the perfect tool for cutting these pieces. This is the Evolution 355 MCS, and it is a chop saw where it cuts both ways up to like 47 degrees. This thing is awesome, and we're going to need that feature for this because we're going to be picture framing the corners on this angle. And what I mean by that, when I say picture framing, these corners are going to be mitered here and here. So this is the side we're keeping, this is the scrap. So I need to set my saw blade up accordingly, and I need to make sure that the saw is cutting the blade to the right side of the line and not this side, because this is the side I want to keep. That's the scrap. These saws are loud, so you want to make sure you got hearing protection and eye protection. $49.5. Perfect. We just finished cutting this piece. Now the next piece we're going to cut is this one right here, which is 32 inches long. And that's 32 inches from the outside point of that miter to the end. So we're going to cut the miter first, then we'll make it 32 inches long. And that's what's so great about this saw. You just loosen up this right here, and then turn your saw to 45 degrees, and it locks right in positively right there. And we'll put the stop down on the material just like this. Lock it down. Put another one here to lock it positively against the fence. And there we go. Now if you just want to check to verify that that is spot on, you just take a framing square. Boom, look at that. Perfect 45. We said we needed to make this piece 32 inches long to that long point right there. So here's the long point right here. We just need to measure back 32 inches. And the great thing about this, guys, is that this cut has no heat in it. It's burr free, it's super clean and accurate, and it doesn't leave sparks all through your shop that can burn your shop down like a regular abrasive wheel can. These are the chips that it creates. They're just little small pieces of metal. The next piece I gotta cut is this one right here. This is gonna have a mitered cut here and a mitered cut here. So now we've got our saw set this way so we can make a miter in this direction. Then we'll measure back 23 inches and do a miter in the other direction. I had a little issue here with this part of the saw contacting the height of this angle, so I had to cut it off at 23 inches and then make the 45 cut, but that wasn't a big deal. But like I said, that's resolved if you just cut it off square, then make your 45. from the outside edge of this angle to the outside edge of this frame, you can see that's 23 inches, outside to outside. So outside to outside needs to be 23 inches as well on this side. So that means to do that, we got to make this 3/16 of an inch shorter because that's the thickness of this angle. So it's going to be 22 and 13/16. So the rough shape is all made now. This is where the plate is going to be on the end, the 4-inch flat bar. But now we got to do some coping cuts. We got to cope out this, you can see right there, so that this sits flat right here. So that means we got to take out this piece of this web here, and we got to come up 3/16 and across this right here so that that sits flush. And we got to do the same thing on this side over here. And we can do this with the bandsaw. I think that's probably going to give us the cleanest cut. And that's as simple as just butting that up there and putting a line right on the metal. Right there. So I just put a straight edge on it. So that's what we got to cut out, right where that X is. And then we got to cut across there a little bit. Piece of cake. So to cut along this, which is 3/16, we're just going to turn this up on edge, just like this, and cut to the end of that line. Now I'm using my portable bandsaw stand that I made for this saw. Super easy. If you have a portable bandsaw, really you should invest in building one of these stands because you will get so much more use out of your portable bandsaw. I use this all the time. All right. And that's a coped cut right there. You can see how nice that fits now, all around there, all around there. Gives me a lot of area to weld, like all along there, all along there, all up there. Same thing on this side, here, over, and I could even bevel it out and do the bottom side as well. So now we just gotta cope out this joint here. Just put a little mark right about there. Carry that across and cope that joint out. I've laid this out all along the length and made marks fairly equal distance that'll work out good for as far as drilling the holes to secure this to the wall. I've center punched this one right here so that I could bolt my drill vise to this table, and then I can just slide it along the length of it and it'll put the holes perfectly in alignment. This is a 1/4 inch bit. This is going to be for my pilot, and then we're going to go with a 1/2 inch. I thought I had a 1/2 inch annular cutter. The smallest annular cutter I have is 9/16. Now I've got a 1/2 inch drill bit chucked up, and we'll just drill down through our pilot hole that we just previously drilled. I was going to use a plasma cutter, but I figured rather than set up a brand new tool, this is right here, might as well use this. So now this is 4 inches by 8 inches, all set to go. Now I'm going to work on my joint prep. So wherever there's a weld to be made, I'm going to bevel it back, get everything all cleaned up, get all the mill scale off it, so we got a nice, good, solid connection. Now that I've got all the edges prepped, guys, and you can just see kind of here what I've done, I've kind of beveled everything, cleaned it up, got rid of the mill scale. Now I can start fixturing all this up, and it makes it really easy with this table. I built this fabrication table. These are some shoulder bolts that help align everything and make everything square. So all I do for this is just drop some of these pins down inside the table. So that makes a straight edge here. Do the same thing over on this side. They fit really tight down in these holes like this. And now with this pushed up against these, this pushed up against these, that makes for a perfect 90-degree corner. I just clamp this down, tack this up, and then go all the way around, make a complete square, and then this is perfectly level, flat, and square. It just makes layout and setup so easy. Then just throw a couple clamps on it. Also, I made these as well. The next thing we want to do is start welding this out. Now, if I was outside or on a job site, the perfect process for this would be to stick weld it. We're not on a job site, we're inside in a controlled environment, so that makes this a perfect job for MIG welding with C25 gas. I'll take a minute to go over the setup. I'm using my Fronius Transsteel 2200. For wire, I'm using Lincoln 30 thousandths. I'm using C25 gas. So if we look at our material thickness gauge here, it says that 3/16 material is 0.187 thousandths. So we go to our machine and we're set on material thickness. So we can go to 185. The next one up to 190. So we'll go 185. We're on steel. We can purge out the line and also see what we're running for CFH. So that purges out the gas in the whip, and that lets me know I'm running about 18 CFH. Press it again, that turns it off. You can see we're set for 30 thousandths, C25 gas, and that works out to be 26.9 volts. So we're all set up with this machine to start welding. I went up to 27 volts, guys, just because it felt a little cool. Because there's very little surface area around this, I took this corner where I started and wrapped it around this way, and now where I started here, I started a little bit beyond the corner. You see how I did that? And wrapped it around this way, so that way there's no break inside the corner. I'm going to give it a little bit more strength. There it is, guys. Just got to clean it up with a wire wheel, and then we'll throw a coat of black paint on this and we'll get it off to the customer. I asked if they wanted me to put any holes in this plate over here, and they said they didn't know at the time how they wanted the whole layout to be, so they said they'll drill it in place. But I did ask before I went and installed this, because the time to drill the holes in this would have been right before it's welded on. That way you could drill them on the drill press. Now I'm going to give it a good wipe down with some paint thinner. Then we're going to brush on some nice black paint to help protect the finish. And I just lightly wire wheeled everything as well, guys. Just kind of went over it in places with a flap disc and wire wheel to take off any debris or BBs or anything that was left on it. Kind of take your hand and run it over it. I'm just going over it with some rust-only paint. Now, because this is going to be some type of hoist, guys, you want to protect yourself and let your customer know and make it aware that any brackets or anything that are used, you know, to lift materials or people need to be signed off by a structural engineer, because you're not a structural engineer. Because this is going to against a wall, and then out here this weld was ground and that one was ground on the outside to give a good appearance and so that it fits flush. This part is going to be exposed on the bottom part from what I understand. And yeah, it's all painted up, all looking good. We'll let this dry and we'll get this back to the customer. Anytime you're building something like this that could be used to hoist either materials or people or whatever, you don't know what they're doing with it. On the invoice, I will actually write, I am not a certified engineer, and that this bracket be certified and signed off by an engineer. And that way that'll protect you as far as any liability if they go to, you know, use this and they're hauling people with it. And the person that designed this, it wasn't me. I didn't come up with this design. I'm just building what they told me to build. And if the person who designed this isn't a certified engineer and something happens and someone gets hurt, that's going to be liability on you. So always make sure you have stuff in writing. That's the biggest probably piece of advice I can give you, is have stuff in writing and be very clear when you're doing something and what your intentions are, so that your customer fully understands that if they're going to do something with this bracket that could haul people, and if the bracket fails, that it's not on you. And that's not to say that you'll ever get sued, because there are actually people who literally go around looking for lawsuits and slip and falls. Someone who will drive down the road and lock their brakes up intentionally so that you rear end them so they can get a paycheck. So there's always somebody out there looking for a scam or to make a quick buck. So all we can do is try to protect ourselves best we can. And another thing you're going to want to do, guys, is look into forming an LLC if you're going to get into some part-time work or even full-time work. And an LLC is a limited liability corporation. That'll help protect you and your assets. And another thing you may want to look into is trademarking, because people like to steal from me and they like to use my logos and represent my original artwork as their own. I've had to go out and trademark my stuff, and trademarking is going to cost you at least $1,000 to do it. But that way, when somebody wants to go out and portray themselves as you, you can legally go after them and financially go after them for compensation for damages that they're causing you by representing themselves as you and making a profit off of you and your original artwork, or, you know, your brand. Get yourself an attorney, someone local to you that kind of specializes in that stuff, and they'll walk you through it. You know, to form an LLC and trademark some of your stuff, it's going to cost you a few $1,000s, but it's well worth it in the end if you're not losing all your assets and everything that you worked hard for because, you know, some creep went out and was looking for a payday and they went out and sued you. And that's all there is to it, guys. Until the next one, I will see you then. There's new videos every Friday. I hope you enjoyed this episode, and if you did, please consider giving it a like, comment, subscribe, and share. Until next week, guys, I will see you then. Take care, stay safe, and God bless.